Set up, but do not evaluate, an integral that represents the length of the curve. Here we're given that the curve is represented by the parametric equations x equals the arcsine of t, y equals the natural log of the square root of 1 minus t squared, and t is between 0 and 1/2 inclusive. So our arc length formula for a set of parametric equations is the integral from a to b square root dx dt squared plus dy dt squared dt. Our limits of integration, namely a and b, are the same as our endpoints of the interval that t lies on, and then we need to find out what dx dt is and dy dt is. X we know is the arc sine of t, so we just rewrite it down here. Y is equal to the natural log of square root of 1 minus t squared. Remember, that's 1 minus t squared to the 1/2. And if we wanted to be extra clear, we could put those brackets there. They're not necessary, but just to be clear that that is all inside the natural log function. Okay, so dx dt is the derivative of the arc sine of t with respect to t. That's 1 divided by the square root of 1 minus t squared. The derivative of y with respect to t, well, we have a chain rule here. We have natural log of something inside that. So the natural log is the outermost function. The derivative of a natural log is 1 over, that's 1 minus t squared to the 1/2. But then the chain rule says you must multiply by the derivative of the inside of the function. The inside is 1 minus t squared to the 1/2. Well, within that, we actually have an inside and an outside as well. The 1/2 power is an outer function, and the 1 minus t squared is the inside. So if we take the derivative of the 1/2 power, we're going to have 1/2 1 minus t squared to the negative 1/2. Remember, to take the derivative of an exponent, you bring down the exponent, in this case the 1/2, and you subtract 1 from it. 1/2 minus 1 is negative 1/2. Now the chain rule applies again, and we multiply by the derivative of the inside of that. The derivative of 1 minus t squared is negative 2t. So this derivative is a little bit nastier than the derivative of x with respect to t, but it's okay. dy dt, we do a little bit of simplifying just for convenience here. This 1/2 and the 2 in front of the t, those will cancel. The negative exponent of this whole factor drops the factor into the denominator. So let's just write a couple of steps here to be clear. So this is 1 over 1 minus t squared to the 1/2. Then this is going to be another 1 over 1 minus t squared to the 1/2, because again, this negative exponent is going to drop that factor into the denominator, and now in the numerator we still have our negative t up here. Remember, those 2's canceled, the 1/2 and the 2 canceled, but the negative remains. So lastly, for dy dt, remember, to multiply fractions, we just multiply straight across. We do get the chance to cancel, but there's nothing left to cancel here. So we just multiply straight across. 1 times negative t is negative t. 1 minus t squared to the 1/2 times itself, well, you can add the exponents. So 1/2 plus 1/2 is just 1. So we have 1 minus t squared to the 1 power, which we may leave off. Again, just to bring it down so we have them in the same place, dx dt is 1 over the square root of 1 minus t squared. Okay, so we have dx dt, dy dt. Just to remind you, we have our limits of integration from 0 to 1/2. So we're ready to write our integral needed. So the arc length is the integral from 0 to 1/2, the square root, dx dt squared, 1 over the square root 1 minus t squared, plus dy dt squared, so negative t over 1 minus t squared, dt. So there's our integral, which represents the length of the curve on the interval from 0 to 1/2.